Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to look at Microsoft Azure and the integration that they have built in cooperation with the Spring team to support that use of that platform. Okay, now I'm a big believer that of course you should whenever possible take full advantage of the platform on which you're running, where you find compelling, differentiating services, and Microsoft Azure is chock full of them. Naturally, I'm always of the sort of position that you shouldn't couple yourself to a particular platform uh, unnecessarily, of course. So it's for this reason that Microsoft's nominated Pivotal over many years to be their sort of number one partner. Right, we're a good partner because we drive app instance consumption on their platform. People use Cloud Foundry, Pivotal Cloud Foundry, on top of Microsoft Azure, and this is a very natural pattern, a very natural sort of arrangement. People use Microsoft services, infrastructure, things like that are managed by Microsoft that provide value to applications that are differentiating things on that platform, and then they, where necessary, use those, but they also don't couple themselves to that particular platform just because they don't need to. Right? There's no reason in this day and age to couple yourself for things like running a Java or Node application. Right? So you can use Cloud Foundry or at the worst, you could use something like Kubernetes, but either way, you have this sort of bit of indirection between your application and the underlying platform. So what I want to talk to you today about is how to use Spring Cloud and Spring Boot along with Microsoft Azure, the integration for Microsoft Azure, and that development, that integration is something that I regard with optimism and enthusiasm, because I've been privy to its development. I've watched it grow from all of nothing from a couple of years ago to this really compelling sort of integration that reasonably full featured. It grows pretty quickly. The teams are the teams that develop it. I've had the privilege of working with the teams that work on it in both Redmond, where of course Microsoft is headquartered, and in Shanghai, China. So it's just nice to see this integration grow so compellingly, so usefully, in just such a short period of time. And so today we're going to build a very simple application. We're going to call this Bootiful Azure, and we're going to use the Azure support. We're going to use Azure storage, but really there's a bunch of other starters that we're going to add along the way, but really the only one we need is support. I'm just adding storage because that's just one less thing for me to add in manually later on. We're also going to use the web support, the Lombok support. We're going to use SQL Server, right? That's actually not even part of the integration with Microsoft's. That's not part of the Spring integration from Microsoft. That's just a thing that Spring Boot does for you today. There's nothing particular about that. You just add SQL Server just like you would MySQL or Postgres or H2 or any other sort of stock standard SQL driver. So we're going to add SQL Server. We're going to add Actuator. That's nice. I'm not even sure there's a particular reason to use it here. It's just nice to have that. It's always good to have that. And I think that's it. That's it for now. So we're going to go ahead and generate a new project. I'm using Spring Boot 2.0.6. And that'll be it. Okay, so we'll hit generate, and we're going to open this project up in our IDE as usual. So here we are, cd downloads Azure opalm.xml. Now we're going to be using Microsoft Azure. You can get, it's pretty trivial to get a free account. You can sign up, and they even have like they have a free trial that gives you some free credits and all that kind of stuff. I'm not sure of the specifics, but I have an account as well, and I'm already logged in. So I'm going to go to the portal, to my account rather, to portal. Come on, hello. Here we are. And when you get dumped into the portal, you're confronted with all these sort of amazing things that you've got there. I've got some favorites in my dashboard here, but you can see that if I go to create a resource, there is a whole galaxy of things I can play with here. Right? There's blockchain and identity management and security and different kinds of messaging technologies for IoT versus transactional versus messaging, venting and storage options and AI and machine learning and all this really kind of interesting stuff. Compute primitives. I wouldn't necessarily use any of these. Actually, these are, I think, a little low level, and they're sort of they miss the point, which is that you shouldn't need to use these things to couple yourself to the platform. Use something like Cloud Foundry, but good stuff like that, right? Lots of interesting stuff here. There's even tutorials you can follow, so that's nice. I mean, it's just really, really compelling. I've got a few things already provisioned in my account here. I can see the resources that I've got. I can see all that kind of stuff. If I go to my dashboard, dashboard. Oh, actually, that was pretty kind of an interesting view. Look at that. All services shows you sort of an expanded view of all the things that are available to you. And I think that's really compelling. I mean, you can see here, for example, you've got Cosmos DB, you've got SQL Server, you've got Redis, you've got Databricks, you've got event messaging. I mean, just all this really good stuff that you should absolutely feel free to look at and explore. And this richness of options is why, at the moment, I should qualify, because who knows, it changes every 5 minutes these days. Things are moving so quickly in this particular space. But for the moment, Microsoft Azure is the number 2 most prolific, most entrenched infrastructure as a service offering after Amazon, right? And so it's a really compelling story. There's a lot of good stuff here, and obviously very few organizations understand enterprise like Microsoft understands the enterprise, right? That goes without saying. They've got a pedigree there, rivaled by very few others in the industry. So they know the use cases that enterprises will care about, and of course, Spring is very entrenched in the enterprise as well. So it's nice that these integrations work so well together. So what we're going to do today is, now that we've got a new application up and running, we're going to build a little application that uses some of the stuff in Microsoft Azure. Now, you can actually use Microsoft Azure from the command line. There's a command line tool you can install on your local machine, or just use the Cloud Shell. So I clicked up here on this little arrow, and I clicked on that, and it's going to launch the shell right here in the browser, and I'll be dumped into a Unix Linux shell that has access to the command line that I can then use, and it's already pre-authenticated. So I can do, I hit AZ and I get all the options here and so on. So you can certainly do that, or you can just use the console, the portal itself. And I'm going to just use the portal, and because I've already pre-provisioned certain things here, I'm not going to spell out how to provision all this stuff this time, just because it takes a little while sometimes. It takes a little while, and I don't want to chew up screen time just waiting for stuff to provision. But it is easy to do, and there's a lot of ways to do it. One thing that's kind of interesting about Microsoft Azure is that they have what are they called? Azure Resource Manager templates or something like that. ARM files, basically. Basically, these files are the bread and butter of the platform. And so there are REST APIs that you can use that take these files as inputs. There is the user interface, which just creates those files for you, and then it transmits them as well. And the command line, all that does behind the scenes is it creates these resource files. So you can actually, if you want to automate things, you can just get a hold of these template files, these files that are used to describe how things should be provisioned, and then store them, version control them, and transmit them again later. And that makes it very easy to reproduce things, right? The entire platform is built that way. This is different from, for example, different from, for example, AWS, where CloudFormation was an afterthought. It was added later on, right? So, okay, what do we want? What do we want to do? Well, I want to build an application. Let's just start with the simple stuff. Actually, I didn't add JDBC, did I? I'm going to go ahead and add the JDBC support here in my Spring Boot application. And we'll say dependency, Spring. Okay. Spring Boot Starter JDBC. And again, this isn't even a Spring Cloud thing. It's just regular old JDBC support. I want to be able to use JDBC. And again, you've probably used the JDBC support in Spring before. This is not particularly new, but what I want to do is I want to talk to SQL Server, which is, awesome. I don't know if you've ever used Microsoft SQL Server, but I don't think many would deny or argue that it is not one of the sort of gold standards of SQL databases out there. It has been around forever and a day. It is I think it's up there with Oracle's database and Postgres as being one of the most fully featured databases out there. And here you can provision a SQL Server on Azure, fully featured. You can do geographic redundancies, you can do threat protection, you can do all this sort of stuff here. You configure a username and password, you give it a resource group, and the resource group is nice because you can log into your portal, delete the resource group, and then everything that's in there gets deleted as well. So you can reset that back to zero with no pain at all, right? And by the way, see that? It actually created a resource group for the storage required to store the transient ephemeral log files and PIDs and whatever else is getting created in my little Cloud Shell Europe here region here. And I'm actually in Zurich, Switzerland as I write this, so it created one in, guess where? West Europe. How cool is that, huh? So I'm using the Bootiful Azure one. I could do that. I could create the region. You can do all sorts of interesting things there. Automation options. What do you got there? You gotta have all that. But I'm not going to do that. I've already got one. I'm going to click on this instead. Hit OK. Yeah, thank you. Close that down. And when I click on Bootiful Adventures, that's the server that I've got. Okay, and the server, I can configure access to it through Active Directory. That's another thing that's compelling. Every organization in the world that I've ever with which I've ever interacted has used, of any size really, uses Active Directory. Right, it is just a very entrenched technology, especially in larger organizations. Nowadays, you see a little bit more Google Cloud, Google Apps for your domain, but nothing nearly so prolific as the Active Directory suite. The Outlook and Active Directory combination, right? That is the most entrenched thing in the world. So to be able to have Active Directory in the cloud, to be able to just point and click and get yourself an Active Directory that integrates with other Active Directories and so on, is unique. It's valuable. It's interesting. So the fact that I can now talk about access to my SQL Server in terms of these Active Directory roles and users and so on, that's awesome. I've got my SQL databases. Remember, I've got one server, but I can have multiple databases here. And I've got one database here called Bootiful Adventures. Now, of course, you could create your own database. So this is my server. I'm going to go to here, click New Database. And when you do that, you can provision a database name, and then you can provision a source. And you can see, you can configure a blank one. But what I did, and literally all that I did, was to create a sample using AdventureWorks LT, which is a fully featured schema that has some sample data in it with which you can work. You can configure that you want this to be an elastic SQL pool. You can configure the pricing tier. You can configure the collation. I mean, all that kind of stuff that you want. And then you get a database. I've already done that, of course. Okay, I've already done that. So here is my database. Where is my database? Ooh, I just lost it. SQL databases. Bootiful Adventures. Click on this. And now I'm given information about the database itself. I've used a total of my 11 megabytes of space out of my maximum 250 gigs. So I think I'll be fine. For this particular demo, for this screencast, I think I'm well within safe levels. Okay, I don't think I'm going to need more. But look at this. There's some really nice things here. I was just talking to people on Twitter about this the other day, and one thing that Postgres doesn't seem to have yet that some organizations love is transparent data encryption. This is one of the things that really, really expensive databases like Oracle and, of course, things like SQL Server have out of the box. That is to say, you can have the database configure encryption for your data in the database, right? This is even more critical today in the world of security hacks and everything being vulnerable. These kinds of things are just there. You just automatically get them for free by using these fully managed, scaled, backed up services, and these are valuable. So there you go. We've got a SQL database. I'm going to use the query editor here. I have a configuration file, so I'm going to copy this configuration file. Desktop misc Azure dot. What did I do with it? Oh, I put it in here, didn't I? Configs, there we go. Azure.properties. I'm going to copy that to source main resources application.properties. Okay, and I am going to delete everything in that resource group, just like we talked about, as soon as I'm done with this. So I've got this configuration here. Here are my keys and passwords and all that kind of stuff. I have a password, springtime, for my SQL database. I'll log in there. And I get this nice editor. I can actually log in and interact with the data and the tables and all that. I've got tables, I've got views, and I've got stored procedures, all of which I can work with here, right? So I'm going to say select all from saleslt.customer, okay? Hit go, run, okay? And it gives me all the data. There's actually a fair bit more data here than I want, so I'm going to use the SQL Server variant of limit. So it's like top 10, for example. Okay, get that back. Or you can just select top 5, get that back. There we go. That fits into a nice, simple range. So I've got a customer ID, a first name and a last name field that I want to observe. So let's use that. These are for customer records. Okay, so let's create a thing that manages customer data. Okay, so class SQL Server demo. Okay, and event listener, application ready event. Alrighty, application ready event. Okay, and this will be a demo that demonstrates how to use SQL Server, and that's nothing special. We're just going to use the regular Spring JDBC template to do that. Okay, so as normal, it's going to be a regular Spring Bean, so we'll make it a component like so. We're going to create a SQL query private. My computer is dragging because I'm using QuickTime. Okay, there's my query. Very simple, couldn't get simpler. And I'm going to inject my JDBC template and inject that into the constructor. Okay, and all I'm going to do is I'm going to load the records in the database and then print them out. So public static class customer, it'll be a data class with all the constructors, no args constructors, all that kind of stuff. Private string ID, what are we going to call it? Customer ID, private string first name, last name. All right, there we are. And I'm going to map that data. So I'm going to create a row mapper here. Okay, row mapper of type customer, new row mapper. Okay, and my job is going to be very simple. When I'm given a result set at a certain offset, which is indicated by row num, I'm going to turn it into a custom object. So rs.getLong customer ID, rs.getString first name, rs.getString last name. All right. There's my simple row mapper. Did I say string? I meant long. All right. Good stuff. Good stuff. So there's my simple row mapper. That, of course, can be written as a lambda, which is nice. And then I'm going to use the JDBC template. I'll say this.jdbc template.query, this.query row mapper. Okay. And, I suppose I could just put all that in the method itself. It's just going to run once after all. It doesn't really matter. It's almost redundant. I could have just inlined it for that matter, but it's easier to read, I think, broken out like this, especially with my font size being so large, so as to benefit our viewers on YouTube and so on. Customer list for each, and I'm just going to log out the result, aren't I? So I'm going to use a log4j logger that I've got here. I'm going to inject that. Okay. So there we go. There's my logger. There's my application. I'm just going to print out the data in the database when the application starts up. So we'll go ahead and run this now and see what we get. In order for this to work, notice that we've got here a spring.datasource.username and password and so on. I got the URL here, by the way. Let me go ahead and start this while we're waiting. I'll talk about the configuration here. So I've got the URL, and the URL you can get by going into your database here, and you go to, is it configure? I always forget about that. They seem to keep the credentials and the relevant information under different screens. No, that's definitely not it. So we go to SQL databases. Click on that. connection strings. That one's pretty straightforward, isn't it? Look at that. So there's the connection string for ADO.NET, JDBC, ODBC. ADO.NET is the way you configure. It's the framework for connecting databases in .NET. Microsoft's .NET platform. ODBC is the Windows database connectivity API. It's an abstraction that's unique to Windows. Although I think now you can actually talk to that. You can use the same SPI in Linux in certain cases. And then there's this thing called whatever that is, and then JDBC. Okay, and JDBC is what we've already got this here. Notice that the password is not specified, right? So you have to actually plug that in. And I actually did. I just said I took the thing that it gave me and I just added a $sign and I just said SQL Server password, and that's actually the SQL Server password from here, right? That's actually encoded. Although you don't need to do that. I could just specify the password value like spring.datasource.password. Okay, so there's that. Now we've got that. What happened here? Oh, I need to comment out some of the stuff that we're not using just yet, because otherwise it's not going to work. So, good. Okay, there's my SQL Server. Okay. Oh, something's running on that port, isn't it? Okay, let's see. JPS, that's Java Process Killer. Kill 87302. How'd that get there? How embarrassing. -9. 87302. Aha. Okay, take two. Now I've got so right now I'm using Spring Boot 2.06, and I'm using that because while we have Spring Boot 2.1, and Spring Boot 2.1 is compatible with Java 11 and all that good stuff, the Spring integration for Microsoft Azure isn't yet compatible with Spring Boot 2.1, so I'm using 2.06. Spring Boot 2.06 is creakingly old. It's like a month old at this point. I mean, it is ancient, but that's okay. We're going to use Java 8 instead of Java 11, and then when the Spring Boot 2.1 supporting release of the Spring integration for Microsoft Azure is released, then we can rerun this program in Java 11, and everything should just be fine. In the meantime, we get issues about missing JAX-B types, like Java XML bind data type converter. Alrighty, let's see what we got now. Look at that, huh? There's our data. There's the first 5 records. G, Harris, Carreras, Gates, Harrington, etc. Okay? So that's this, okay? We've got that. Now, next thing, I love SQL Server. It is really compelling, as we've discussed. There's some really nice features, including things like TDE for, transparent data encryption for at-rest security. Great, I love that. That said, you could run it yourself. You shouldn't. I mean, you could. Why would you want to run your own SQL Server when you can get Microsoft to do it for you? But you could run that yourself, right? Arguably. What I want when I go to a public cloud, I want to take advantage of things that are really unique. Things like Cosmos. And Cosmos is a database that speaks multiple protocols. You can talk to it through Cassandra, through MongoDB, through SQL APIs, and it can model data in a number of different ways. I've got a Cosmos DB instance here. It's geographically distributed. It's highly available, easily to replicate. I can actually see this. I'm not sure if you can see that. If I click on the region configuration here, I can now, my mouse, let me see if I can make this a little larger for you. I've got 2 instances of this data, right? And right now they're configured in Australia, because when I configured them, I was in Australia. I'm going to go ahead and just remove one of them. There you go. It's no longer that data. My data is no longer available in that region, but I'm going to make one available here in, where am I? I'm in Zurich, so West Europe. Let's do that. There we go. Now I've got geographically distributed data in 2 different regions in the world. Just as simple as that. I'm going to go ahead and remove it from Australia. There we go. Okay. So that's that. That's all you need to do to get data, consistently available across different regions, and they're billable, of course, through my account. One thing I should stress, I didn't really talk about this, but I'm pretty sure that I saw somewhere that Microsoft Azure has the most regions in the world. That is to say, oops, failure. I need to have 2 regions, do I? Let's do that. Hit save. I'm not sure what I just did. Discard. Okay, let's add this over. Hit save. Okay, I'm adding a region. I think you need to add a region before you can remove something. Okay. Are we happy? Looks like we're happy. Now, can I remove one? Oh, it's updating. So now it's doing the writes. It's actually doing the, replication. Microsoft Azure has more regions than I think any other cloud vendor. That's what I saw, at least. I'm happy to be wrong on that, but they have a really, really large list of regions available. They even have a region available in China. Now, this isn't strictly speaking Microsoft Azure. It's because of the way people have to do business in China. It's a white label version of Microsoft Azure that runs on a cloud that isn't Microsoft, but it is Azure, and it's 6.5 of one or half a dozen of the other. It's the same thing. It's just not quite the same thing. Okay, and it's charged differently, and there's certain data provenance rules that are different there. But the fact is, it's there, right? You can use and rely on these APIs in just all sorts of different regions. I think there's a government compliant one, U.S. government compliant one. I mean, a German compliant one. There's all sorts of new regions. So that's doing its thing right now. It's updating. We'll see what happens. The fact that it is just a few buttons to make that work, that speaks to why Cosmos is so amazing, right? I have some collections. I've got some data here. I'm going to browse the data while that's doing its work. And I can see how much data I've got. I've got this reservations collection, okay? And what I want to do is I want to talk to that data using the Cosmos DB Spring Data integration, okay? So if I click on this, okay, let's see what we got here. I can add collection. I can click on the existing collections. I can see the documents in that collection. Now, this is weird. Documents and collections feel like MongoDB, and yet I've got records here that look like MongoDB BSON documents, but I can query it using a SQL query, right? Or a stored procedure, lots of options. UDF, trigger, a new SQL query. Lots of different interesting things you can do here. I've got some records here. I'm going to go ahead and delete all the data. Okay. Oh, that didn't work. You know what I could use to make this easier? I can use the Azure Microsoft Storage Explorer. Now, the Storage Explorer is a separate Electron-based application that runs separately, right? And you can use it to talk to, among other things, your Azure storage account and your Cosmos DB document, which is pretty cool. So now I can log into that, go into the document there, documents, and delete. Does that work? Well, guess not. Okay, delete that. I thought I could bulk select them, but doesn't matter. What I'm doing is I'm deleting the data in the storage Explorer. And now if I go back to here and do a refresh, come on. There you go. You can see there's nothing left. Okay. Okay. So now I want to use the same thing. I want to use the same document in the same Cosmos DB account and talk to it from my Spring application. Meanwhile, you can see that the read and write locations are now available in France, Central, Australia, Southeast, and West. So I'm going to go back to this and disable 2 of the other ones because I don't want all those. I just need a few of them. I just need one. I'll take Europe. That's fine. So we're going to go ahead and delete Australia East. Okay. And then get rid of that one as well. Hit save. So my data has been moved to France Central. Of course, there is no data, so I suspect that makes the migration even easier. I'm going to go back to the database, the Cosmos DB database here. And I'm going to now write some data. Now, I'm going to be kind of interested to see what that looks like if I start writing data to this while I'm deleting one of the other regions. But anyway, we can do that very easily thanks to the Spring data integration. So I have a data of type reservation. and I'll make this a data object. It's going to be using Lombok to handle compile time annotations and that kind of thing. It's going to be a table. Sorry, document. No, it's a table. I need to add, oh right, I need to add the Spring Boot Cosmos DB starter. So let's go back to my build here, and I'm going to add the Cosmos starter to my build, and the Cosmos starter always eludes me. It is Azure Document DB Spring Boot Starter, Microsoft Azure, voila, okay? And that's managed for us by the Microsoft BOM, the Azure Spring Boot BOM, Bill of Materials Maven build. So with that in place, I can create a table, or is it a document? So, yeah, it's a document, and the collection name will be reservations. All right, I have a document of type string ID, and another one whose field is name. Okay, and I could call this reservation name, and I could map it to a column if I wanted to. I guess not. Just name, I think. Let's just go see what I've got here. Browse. Collections. And I suppose it doesn't really matter because we've got no data in there, so it's ragged. Let's just make it name there. This is the ID, and there we go. There's our simple entity. And I'm going to create a repository to manage that. So reservation repository extends the document DB repository, and the entity is of type reservation, whose key is of type string. And by the way, I'm using Spring Data Cosmos. I'm using Spring Data Document DB support here. I could have used Spring Data JPA, for example, using SQL Server. And one thing I could have also done with SQL Server in particular is I could use the R2DBC support. So R2DBC, github.com, R2DBC. R2DBC is a reactive SQL data access SPI, and right now it features, again, these are talking to natively reactive SQL database drivers, supporting H2, supporting Postgres, and supporting just last week Microsoft SQL Server. So I could do a reactive SQL Server, integration here as well, right? That's pretty interesting. So that would be supported in the new Spring Data JDBC, and for both SQL and for both reactive and non-reactive variants. Okay. So anyway, Spring Data document DB. I've got a repository, and now, same as before, I'm going to use the Cosmos DB demo. I'm going to write some data to the database. It's going to be a bean that starts up, listens for an event listener, application ready event dot class, public void demo. Okay. Throws exception at component private final, and here I'm going to inject my reservation repository. Okay, I'm going to write some data. Let's actually create that, inject that in the constructor, and we'll write some data. So stream dot of A B C dot map name new reservation null name. Okay, and then map r this dot rr dot save r dot for each log info. Okay, and as before, I'm going to use Lombok to create my little logger there. And that's it. Now, I also want to delete the data. I don't want to have duplicate data before. So this time, .rr.delete all. Okay. So there we go. There's our delete all, and then we're going to write some data to the database. Let's restart this. In order for that to work, we need the Cosmos DB configuration. I'm going to tell it what URI key and database to use, like so. We can get that information by going into our portal, going to Azure Cosmos DB. And you can see here when I click on this, it shows me keys. These keys are what I need to get the information. So there's my URI, my primary key, and my secondary key, my primary connection string, and so on. All that fits into this, and of course the name of the database is self-evident, Cosmos DB reservations. Okay, so with that in place, we can now restart the application, and now we should see not just our SQL Server data, but our Cosmos DB data. Two different types of databases, each of which we can talk to in very idiomatic Spring style. Okay. Now hopefully that's that query is much faster. Oh, it is. Look at that. I got the Cosmos DB data immediately. I mean, it was really quick. There it is. There's my 3 records. We should now, if I go to the portal, if I go here, Cosmos DB, go there, go to the documents, browse collections, document explorer. There we go. There's our 3 records. A, and here's C, and there's B. Huh? Not bad. So, okay, we've got Cosmos, we've got SQL Server. What else can we do? Well, what if I want to store actual binary data? You know, here I've got, you know, highly available, highly consistent data access for, you know, records. But what if I have just unstructured blobs of data? You know, well, here I can use the Microsoft Object Storage service, right? So that's easy enough to do. We just need to bring in the right dependency here. So we bring in Azure Document DB Spring Boot Starter, add that to the application, and here I'm just going to write some data. Let's imagine I've got a photo of a cat that I want to store, and I do happen to have a photo of a cat that I want to store. Here, go to the cat. There it is. That's my cat. It's a fat cat. It's a blob. And we're going to use a blob storage service, so that's kind of nice. We're going to upload this cat into downloads, source, resources. Okay, paste. And I'm going to now upload that cat to the storage service. Now, of course, I already have my storage account. I can look at the storage account here. I can see I've got blob containers. And I've got file shares, refresh, right? What is this? That's the data. No, I want the blobs, files. There we are. And this is nice. I can actually take all that, delete it. Just delete, and you even have soft deletes. Did you see that? That's pretty cool. Now here's what I want to do. I could just drag and drop, right? Q uploaded. I just drag and drop from my desktop, and there's the cat. It's now available in the object storage service. I'm going to delete it again because I want to do I'll upload it myself, right? It's still uploading. Okay. There you go. So I'm going to now delete it. But, you know, this storage service is really convenient. You can upload stuff. I am going to write some code using the object storage service in Microsoft Azure to upload that code, to upload that cat manually. Okay, so let's do that right now. We're going to create well, first of all, do I already have the storage? I think I already have the storage starter. I think that was one of the few that we had on the Spring Initializer already. Yep, there it is. Okay, and we can go back here. I'm going to create a class object storage service demo at component at log4j2. Okay, and here we're going to create a object storage service demo. And what are we going to do? We're going to write data to the database using the pre-auto-configured cloud storage account that we're going to configure in a moment here. We're going to inject a resource. This is the Spring Framework resource. It's a thing that manages, it's an abstraction on things that can produce bytes, basically, sources of data and sinks of data. And we're going to inject that, okay, CSA, and resource will be a cat. Okay, so this dot resource equals cat this dot cloud storage account equals CSA. There we are. Now, which cat, you might ask? Well, this cat, the cat that we have in the class path. So we're going to say class path cat.png or JPG. There it is. Okay. So there's our cat, and we're going to write that data to the database when the event listener gets called. Or sorry, to the storage service when the event listener gets called. Public void demo throws exception. Okay. And we're going to use our particular blob container, right? So if we, where did I put it? Where's my storage service? Over here. If we use this, you can see I've got the storage account. I've got this account here called Bootiful Cats, and I've got a blob container inside that called files. Think of it like a bucket, okay? And I'm going to use the files blob container to write this file to the database, okay, to the storage service. So in order to do that, I need to get a reference to that blob container, and the way I do that is I create a blob client using the storage account. So this dot get blob, create blob. Yeah, there we go. Dot get container reference files. Okay. And what does that give us? Well, it gives us an exception first of all, but also it gives us a cloud blob container. Alrighty. So I'm going to store that for later. This dot files. Okay. Okay. Good. All right. So there's that. And we're going to write some data to the database. We're going to write some data to the database, to the storage service. I think, by the way, I'm pretty sure. I don't know. Let's Google, okay? I don't know. Does Azure Storage Service S3, does it support the S3 protocol? Yeah. No, it does not. Oh, wait a minute. Is that true? There are ways to do it. Look, there's an S3 proxy. So if you are using the Amazon S3 API, it's possible to then use that to write data to the object storage service. I'm not sure if that's natively supported now or not, but the point is, you can think of this like Amazon S3, okay? It's just available for you. All right, so now we're going to use the files reference, so this .files dot get block blob reference. I love that word, by the way, block blob, cat. I'm going to create a unique file name, .toString .jpg, okay. Block blob reference, great. And we're going to use block blob reference to upload our data. Which data? Well, the data in the input stream from the cat reference. Okay. And we're going to say in, and we're going to use this .resource.content length to figure out how much data to upload. Good. Okay. And now I'm going to log out the location of that uploaded block blob. Uploaded block blob to block blob reference dot get storage UI. Okay, so that's going to upload a new file every time we run this little program. Okay, so let's restart that and see what we get. Alrighty, so, I don't have the configuration, as I always forget, so I need to have the storage connection. There's my connection string. I'll restart this with that done, but we'll go investigate where we can find that if you want to do it yourself. So you go to the storage accounts. You can see it says Bootiful Cats. Here I can see the access keys. Click on that, and voila, there's all the information you would need to be able to talk to that particular handler, okay? To that storage service. Okay. So did we upload the? Yes, we did. Uploaded block blob to primary equals blah 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 blah. There's the URL. Go to the storage service thing here, and I can hit refresh. I guess it's refresh. And there it's got a U. It's not just cat.jpg. It's cat-uuid.jpg. That's the one we just uploaded. And what do we think? I double click on that. It says initializing open of cat. There we go. There's our blob cat. Okay, so there we go. Not bad, huh? We can actually very easily talk to the storage service that way. And we can also use the Spring resource abstraction to read data from that as well. The next thing I want to do is I want to be able to integrate my highly available cat picture website. I want to be able to support messaging across different nodes to different regions. One way to do that, of course, is to use Azure's service bus, right? And the service bus is fairly straightforward. So you go to your build first of all, and you bring in the right dependency. And in this case, the dependency matches the same sort of pattern as we've used elsewhere. So let's see, Azure. Actually, it looks like this is duplicated. IntelliJ is highlighting it as though it's already been there. So I'll just do that. There we go. So there's the service bus. In order for that to work, you need the configuration just like before. So service bus is a message queue. It's a message bus, right? And so you get the information from the portal as we did before, like this. So service bus. You click on that, and you can see shared access policies. So remember, you're gonna have producers and consumers, which may be different people, maybe different groups. They may not have access to the same permissions, and their view of the world is different. The producer will see the queue or the topic to which they send messages. The consumer will see a subscription that lives on the other end, and it's connected to a queue or topic, but it is not a queue or topic. And this way, it's a much more flexible API than JMS, for example. JMS is pretty naive, right? You have a single exchange, a single destination for both producer and consumer, which means that if you want to change that, you end up breaking one side or the other. Here, I can add a little bit of indirection, sort of like AMQP, right? Which, by the way, I don't think is particularly surprising, given that a lot of the mad science behind the Azure service bus was led by a guy named Clement Vasters, who was prolific in the AMQP community, genius there. So click on queues. These are point to point, right? I've got no queues. You can click on a topic. I've got one topic called messages topic, and I'm going to send a message. And I've got one subscription to that messages subscription. And each subscription has a time to live, it has a lock duration, etc. So I can do all sorts of interesting things there. I can configure all sorts of SLA or QLA information. What I need to specify here is that I've got a topic name called messages topic, and I've got a subscription name called messages subscription. Here, I'm specifying what I want to do with the data. Peak lock means that a received message is not deleted until somebody processes it, right? Here, it's received and automatically removed. So we're just assuming that you've done something with it, right? We're assuming you've managed to work with it. I'm going to leave it in peak lock, and you should too, I think, unless you're sure. And what we're going to do is we're going to write a simple program that it's kind of silly, but it'll work. We're going to write a message that writes a message to the queue, and then we consume it from the same component, the same application. Okay, log4j to private final iTopic client, private final I subscription client. Okay, there's that. And event listener application ready event. Okay, and we're going to just do a demo here that is going to register a listener, a message subscriber first, and then we'll consume the message. So it takes a few seconds or a little bit of time for the registration to settle. So we're going to wait. So we're going to say this dot I subscription client dot register message handler new, and this will be a message handler for let's see, new message handler. Okay. Null. Good. And we've got the injected logger. So let's log that out. Log.info received message dot get body with message ID or body ID dot message ID. Okay, so there we go. There's my message. This is actually a string. I just got a byte buffer. I'm gonna turn that into a string here. New string. Okay. There's that. And that's it. Now you could do some interesting things here. You can handle the errors if they should arise. Your code doesn't have any errors, right? There's no errors in your system, but for others, for the rest of us, this is a nice callback to have. Exception, log that out, very good. Okay, so that's the subscription to the registration. Now we want to use the topic client to send a message. Okay, so new message. Hello at instant.now.toString. Alrighty, and we're gonna hit send and go. Got that configuration. By the way, the configuration for you've got shared access policies. Click on the one that you're using. I'm using this one, and that's where you get the keys, right? The primary connection string and all that stuff that comes from the shared access policy itself, not from the topic or the queue. You may know that, but that confused me for a minute and a half. I'll just say that right now. Oops, this might not work. Oh, did it work? Receiving link. I don't know if I registered. I think I. Let me see. Did that work? Receive message. Okay, good. That did work. I was able to get it fast enough. But usually, or not usually, I suppose sometimes I have to do something like this. And this is a silly example, right? I have to wait a second and then send. So you might, YMV, your mileage might vary. I normally do that. When I'm doing this kind of a demo. Obviously, you're very rarely going to have a silly demo like this where you register to listen for messages that you yourself send yourself. What's the point of using a message queue if you're just talking to yourself? But for two different nodes, this won't be such a big deal, right? Two different nodes across different instances and processes and so on, okay? All right, so good. We've got a whole bunch of stuff here. We've looked at all that. We're obviously, we could take this application. We should store all of this configuration. All of this should be, I would never leave it in a config file like this. This is for a demo. You could use the Azure key vault to store this information, and in which case you would need a bootstrap configuration key that would then use, that would in turn be using an environment variable or something like that. You could deploy this. You could deploy this to the Spring Cloud config server, which supports symmetrically encrypted keys and values. You could use the Nakos from Alibaba. You could use that. I mean, there's a whole bunch of places you could put this configuration. Definitely not in your property file, and certainly not in Git. Right? Whatever you do not check this into Git. That done. I think we're ready to go to production, aren't we? We've got an application. It seems to work. It seems fine. I should definitely write some tests, of course. But that's my first instinct, is I'd love to go to production right now. But of course, we're not really ready to go to production, are we? Not yet. We are. We can't. We have to account for observability. How observable, how visible is this application in production? What can we see about the behavior of the application in production? And so what I want to do is I want to plug in Microsoft Azure Insights, Application Insights, which isn't at the moment managed by the Spring Boot BOM. So it's actually a separate thing that has its own dependencies. So I'm going to use the Azure Application Insights Spring Boot Starter, and I'm going to use 1.10 beta. Okay. And when I have that in the class path, the only thing I need left is the configuration of the name of the microservice, Spring application name. That's just standard. If you've ever used Spring Cloud, you've had to do that before. And the instrumentation key. Okay, and you can get that by going to Application Insights. Click on this, and there's your instrumentation key. Separate place, as usual. It's never in the. It'd be nice if every Azure service had just one screen that says configuration values that you need to talk to this thing right here, right? But nope, it's a little different in each one. But otherwise, really nice API. So here's the instrumentation key. With that, I want to have a REST API. I want to have something I can talk to just to drive some traffic here. So we'll say class greetings REST rest control rest controller at get mapping hi string hello. Because my computer is so slow right now, because I'm using QuickTime, everything, my keystrokes are feeding back later than normal, right? So I'm typing things, I'm not seeing the errors. It's not just you, it's actually me on the producer side as I'm recording this. Feedback is slow. Okay, so I've got my little rest endpoint, and that's because I want to be able to drive some traffic to something that we can then measure and monitor, and so that'll give us what we need. It's just hi, okay, so restart that. Alrighty, so that's up and running, and we can actually make some requests. Curl HTTP localhost 8080/hi. Does that work? Looks like it works, right? So now let's just drive some traffic with it. While true, do done. Okay, and now we go to Application Insights. Click on Bootiful Azure. Live metrics stream. Five, 4, 3, 2, 1. Oh yeah. So it's still connecting. There we go. You can see some data going into the application. Starting to tick up. There we go. Okay. So as it does that, I just Control Seed it. I just Control Seed the request. Let's just see what happens. There you go. It's going to flatline now, right? And you can see that teetering down in certain graphs. So you get automatic instrumentation of all this good stuff. You can see the analytics. You can see how many servers we got online. You can see request rate and request duration. All sorts of very interesting telemetry about the application, all just by having the right key and the right starter. All right, my friends, we have looked at Bootiful, Microsoft Azure. We've looked at the incredible Spring Boot and Spring Cloud integrations. You can see that, like all good Spring integrations, this one supports idiomatic APIs where appropriate and makes it easier to consume these things in a cloud application. You take something like Microsoft Azure and Cloud Foundry, deploy them together, you've got yourself a winning combination that I think is hard to beat, and you're done. You've got a working thing that just works, right? So the platform manages all the infrastructure. You can focus on the code that matters and build world-class services that are built to last and built to scale worldwide in a global scale, in a global way. So with that, my friends, thank you so very much for watching. And as always, we'll see you next time.